All right, the other part of this unit that you have to know is basically about counting, the number of ways to do things. So this beginning part is not really on there, but it kind of like leads up to the other piece. So anyway, here we go. So, how many outcomes are possible when you roll a six-sided die and toss a coin? So this all has to do with like statistics and probability. If you want to know the chance of something happening, you have to know how many different ways there are of that thing happening and of everything happening, and then you want the chance that your thing does. So like let's say that you roll a dice and toss a coin, and you want to know what's the chance that I get a six on the dice and then like a heads on the coin. And so you'd have to know like how many different possibilities there are, because there's one chance of this happening over the total number of possibilities. So, there's six sides to a die, so there's six different things you could happen on a die, and then there's two things that could happen on a coin, heads or tails. So there's like 12 outcomes. So if you wanted to know the chance of this happening, you'd say, oh, well, that's one outcome out of 12. So this counting, it's like you're trying to figure out the total possible ways of something happening. So it has a lot to do with probability, because you're figuring out the total number of outcomes. Okay. All right, how many outcomes are possible when you roll two six-sided die? So you have six outcomes on one and six on the other, so 36. So how many outcomes when you are going to group one of these numbers? So there's 5 numbers with 4 letters, right? So 5 numbers with 4 letters, that's 5 times 4. So 20 different like matchings, you could say. So how many different 3-letter and 4-number license plates are possible? All right, so look, 3 letters. There's 26 letters in the alphabet, right? So you have 3 letters, so that's 26 numbers, 26 numbers, 26 numbers. Now you don't often see like Y, but it is possible to, have the same letter 3 times, so I kept putting 26 here. And the numbers 0 through 9, that's 10 numbers, so 10, 10, 10, and 10. So what you would end up doing is you would multiply all these together, right? So you'd multiply all these things together, and it comes out to like a huge number here. I'm not going to go figure it out. All right, so you see that when you're counting the possible outcomes events, the simplest problems just involve multiplying the number of possibilities in each group. Okay, so next we're going to talk about something called a factorial. So a factorial is used when you're not going to repeat the use of something. Like if I was going to, use the alphabet up here, but I couldn't use the same number twice. So then I would have said 26 times 25 times 24, right? Because I was any time that I use a letter, I don't use it again, so I only have 25 letters less than 24. Okay, so imagine like you had to put these things in order, right? You'd have 4 spots to fill. You'd have 4 letters to choose from for the first spot, then you'd have 3, then you'd have 2, then you'd have 1, right? Like if you use C for the first spot, then you have 3 letters, and then you have only 2, and then 1, and so forth. So this multiplies out to 24. There's 24 different ways you could arrange this. If you had 3 numbers, like think about the numbers. You could do 526, 562. You do 256, 265. Or you could do 625 or 652. Like you can literally see there's 6 different numbers you could make with these 3 numbers, right? So that would be because you have 3 numbers to choose from, then 2, then 1. So that's 6 possibilities, okay? So this notation for what we've done when we're taking a number and then multiplying it by 1 number less each time until we get down to 1, it is, the notation for this is a exclamation point. So when you have a number like here with an exclamation point after it, what it means is you're going to take that number and then you're going to keep multiplying it by 1 less, and then 1 less than that would be n minus 2, and 1 less than that would be n minus 3, until you get all the way down to a 1 right here, right? So like if you had to arrange 6 people in a row of 6 chairs. So, imagine you had 6 chairs lined up, 1, 2, 3, 4, 5, 6. There's 6 people for the first chair, then 5, 4, 3, 2, 1. So basically what you do is you do 6 factorial. And so if you type this into there's a way to put in your calculator, but if you put it into Desmos, oh goodness. So if you literally type 6, and then I think on ABC, if you find the exclamation point, there it is. So 720, okay? So 720 ways to put 6 people in 6 chairs. Okay. All right, how many different 4-digit numbers can you create with these? So that one's going to be 4 factorial. So we did that earlier up here. It's 24. 24 different like codes or whatever you could do. All right, so then we're going to get into something called permutations and combinations. So I'm just going to point to a few things here. A permutation and a combination is usually used when you don't want to use everyone. You don't want to use the whole group. Like if you have like 6 people and you're going to like take 2 of them or something, or you're going to have, 10 chairs and you're only going to put people in 3 of them or something like that. Okay. And so there's what's called a permutation and a combination, and they're different for different situations. So if you have a permutation and you're going to take people, like you're going to take, you have Brittany, Alan, and Greg. And if you care about the order, like let's say that you have those 3 people and it makes a difference of their order. Like for instance, the first person you choose is going to be president. So if you choose Alan first, then it's different from choosing Greg as president or Brittany as president. And then the second person is going to be vice president. So then like Brittany is chosen and then Alan is, Greg. So like Alan, Brittany, and Greg is different than Brittany, Alan, and Greg because they're getting like different offices, right? So when the order matters or when people are getting a different thing out of their selection, that is a permutation. So remember, permutation is picky, right? Permutation is picky. The order matters, okay? Whereas a combination is not important. The order is not important, all right? So a combination is when like, if I had like, 10 people in a room and I was going to pick 3 of them and I say, hey, you 3, I want you to go help me get this stuff from the office or whatever. So those 3 people, they're getting the same job. They're not getting different jobs, they're not getting different positions. Like they're all going to just be part of the same group. Okay. So this information right here, these are the formulas for permutations and combinations. They use that factorial that we were talking about before. But basically, you're going to just be able to understand this. Let's say you had 10 people and you're doing a permutation with 4 of them, like 10p4. So look, a permutation with 4, that means when I pick those 4 people, it's important the order that they get picked. Like the first one's going to be president, the second one's going to be vice president, and so forth. But if I did 10C4, that means 10 choose 4, then I'm just choosing 4 people and they're all gonna like be on a committee or do the same thing. So let's try and put those into, Desmos and see what I mean. So when you do these, you want to go back to your functions and all the way at the bottom, I think. Yeah, there they are. And PR, and you want to put 10, 4 for my example here. All right, and then I'm going to do that again, but I'm going to do a combination to show you the difference. And I got 10, 4. So look at the difference in the amounts of ways. All right, so if you have 10 people and you're just going to pick 4 to like be in a group, there's 210 ways to do that. But if you have 10 people and you're going to pick 4 and it matters the order of those 4, then that's 5,040 ways to do that. So you can it kind of makes sense that like, yeah, if the order matters of the 4 people, it's like you're taking that 210 and then you're multiplying it by all the ways that you can order 4 people. So watch, if I do 210 times what are all the ways that I can order 4 people? Remember, that's 4 factorial. You see how it comes out to that? So it's like you're not only choosing 4 people, you are also ordering those 4 people. And so that's what the permutation, it does like an extra part to the job. So you just have to be able to tell which one do you want to use in these problems. All right. So like when somebody says this, you're selecting 3 students to attend a conference. Nobody mentioned anything about them doing different jobs. Those 3 people are doing the same thing. That's a combination. Selecting a lead and an understudy. Well, lead and understudy, that's 2 different jobs. That's a permutation. Assigning people to their seats. Well, different seats mean different things, right? Like if you sit in the first seat or the second seat, that's a different thing. That's a permutation. Selecting 2 stuffed animals to sleep with out of your 10. All right, well, you didn't say that you're gonna like, oh, one stuffed animal is gonna sleep on the left side of me, one on the right. Like there's no, these 2 stuffed animals, they're just both gonna be doing the same job. That's a combination. President and vice president, those are 2 different job permutation. Okay, all right, so we're just gonna do a few of these and then we're gonna go to the examples on the SOL sheet there. So we don't need to do that. 10 shirts in my closet. I'm going to take 6 of them on vacation. So that would be 10, choose 6 we're going to have. All right. I didn't say when I was going to wear them, like I'm going to wear them on a specific day. I just want to take 6 shirts with me. I'm going to randomly choose them. So it's a combination, right? So here, 14 juniors and 23 seniors in a club. They're going to send 4 representatives. They're all going to do the same thing, right? So how many different ways to select a group of 4 students to attend the conference? So 14 juniors and 23 seniors. That means, 23 plus 14, that's 37 people. So 37, I'm going to choose 4 of them to go. And I would go do that on my Desmos. All right. And then here, if the members of the club, they want to send 2 juniors and 2 seniors. So there was reason that I gave it to you broken up like that. So if I want to do this at the same time, I'd have 14 juniors. I'm going to choose 2 times. Then I have 23 seniors. I'm going to choose 2 of them. And so with that, you would take these 2 answers and multiply them together. So you just get those 2 answers on Desmos and multiply them because you're doing these at the same time. So it kind of goes back into the other thing that we did earlier with basic counting, right? All right. Let's see. In the cafeteria at lunch, there are 3 main course options, 4 side options, and 2 desserts. So you can literally think of this as an easy way. You're like, oh, I have 3 choices, then I have 3, then 4, then 2. Or you can think of it like this. I have 3, I get to choose 1. Times I have 4, I get to choose 1. And I have 2, I get to choose 1. Well, whenever you're choosing 1, if you have 3 things and you're choosing 1, that's just 3 things, right? And 4 choose 1 is just 4, and 2 choose 1 is just 2. So, all right, so I think we've got enough of that. So let's go to these examples here. So on our SOL sheet, oh my gosh, I forgot to do all I didn't see all these at the end, never mind. All right, we'll do those 2. All right, so look, the heights of 200 kindergarten students are normally distributed. I did not realize that this was that too. So I was going for these 2 right here. So I'm gonna go do those and then, let me see. Yeah, do those 2 and then we'll go back and do the normal distribution ones. All right, so let's see, family reunion. I got 8 members. I'm selecting officers. So officers meaning president, treasurer, historian. Those are 3 different jobs. So, one person can't do 2 of them or whatever. So I have 8P3. So I'm gonna go on here, I'm gonna do 8P3. So let's see. So remember, you want your functions down to the bottom. There's your permutations. You want 8, 3. So there's 336 ways to do that. So it's usually a lot more than you think. So 336. All right, a store owner has 3 cashiers and 7 clerks. They want to do a committee, so nobody's more important than anybody else. 1 cashier, so I have 3 cashiers. I'm going to choose 1. So that's going to be 3. And then times, I have 7 clerks. I'm going to choose 2. So I got to figure out what that is. So 7 choose 2. So I want 7, 2, 21. So I have 3 times 21. And if you didn't know that 3 choose 1 was 3, you just do that one also. But I get 63. So 63 ways this poor owner can choose a committee for this. Okay. All right. Now, let me see. All right. So I'm going to go back and do these normal distributions. I thought we were done with it. Sorry. All right, here we go. So the heights of 200 students normally distributed. All right, there we go. The mean is 40, standard deviation is 1.8. So how many students have a height between 38.2 and 43.6? All right. So I'm going to say the mean is 40 and standard deviation is 1.8, but I want 38.2, which would be down here, 43.6, maybe there. So, you know, it's not like a huge amount, but all right, so we want 40 and 1.8 for our standard deviation. So functions, distributions, oh God, I already forgot. 40 and 1.8. 40, comma, oops. 40, comma, 1.8. And we want to find this min and max. I want 38.2 and 43.6. So 38.2 and 43.6. So there's my probability, 0.818. So on my next line, remember there's 200 kids. I'm going to multiply that by 0.819. So about 163 kids, 164. So, you know, these numbers, they would accept 163 or 164, however you want to think of it. Because, you know, rounding will change it a little bit. Okay, and see, answering a whole number. All right, so next page. So here we go. Let's see. We got a normally distributed data for 32 cities. We got the mean is 32.5, standard deviation is 4. So you see how 32.5 is kind of like the middle, like right there, falling in the middle. All right, on the histogram, identify each interval that may have data values within 1.5 standard deviations. So look, what they're saying here, the middle is 32.5. I want to go 1.5 bars above and 1.5 bars below. So it's 1.5 of this number. So 4 times 1.5 is 6. So I have to go 6 up and 6 down. So 6 up would be 38.5 and 6 down would be 26.5. So I'm going to have to choose all the bars that would have numbers in this area. So I would choose 26.5 is my beginning. So I would choose this bar, all of these, and up to 38.5. So 38.5 would definitely include something in here. So you basically would click on all those things. So the understanding though is like this part right here. All right, next thing, it says a normally distributed data set's normally distributed. Here's your mean, here's your standard deviation. And this thing is at 57. There says a data value. They want to know the z-score for 57. All right, so here we go. So z equals, and there's going to be a formula sheet on the SOL. It has this z-score formula on it. So up in the little corner where you click on the different little apps or different little things, the z-score formula is on there, so you can just look at that. All right, x, so we got 57 minus the mean, so 68.42, and then divided by 7.91. All right, so you're going to expect a negative number because 57 minus 68 is going to be a negative. So I'm just going to do this on my phone because I do not want to go back to the thing. All right, let's see. So 57 minus 68.42. I'm going to divide that by 7.91. So we get negative 1 point, and what did they say? Nearest hundredth, so 2 decimal places, 1.44. Okay. All right, and we got 2 more. All right, here we go. Okay, so this is definitely going to be a pain, this problem. There's going to be a few calculations here, but it's not really that hard in the end. So the table shows some data. It gives, all these kids are in different classes and they're doing like a fundraiser, right? And so the mean in Jill's class, the mean number of amount of money raised was 60, and the standard deviation was 11, where her score was 1.8. So what that means really is for Jill, the mean is 60. She's up here somewhere, all right? And because she's 1.8 above that, and the standard deviation is 11. So look, you could do it like this. The middle is 60. You have to take 60 and add 1.8 times 11 to see what her score was, right? Because 1.8 standard deviations, it's 1.8 of these that she is above 60, right? All right, so let's do that. So 60 plus 1.8 times 11. You can also do this. You can also figure out, use a z-score formula, x minus mean over standard deviation. So her z-score was 1.8. You don't know how much she sold, but the mean is 60 and the standard deviation is 11. So look, you're going to multiply this times 11 times 1.8, and you're going to add 60. That's exactly what I have here. So 60 plus 1.8 times 11. All right, that comes out to 79.8. All right, now Kelly. Kelly was above her middle. Her middle was 58, so 58 plus. She was above it by 2.1 of these, by 2.1 times 12. That is 83.2. So she's already higher with her money. All right, Monroe. Now, I think poor Monroe, he was above 55 by 1.4 of 13s. I don't think he's going to be very high. So 55 plus 1.4 times 13. That's 73.2. And this last one. Now he has a pretty high z-score. So, but I don't think he's going to beat Kelly here. But let's see. So 57 plus 2.5 of the 10s. That's 82. All right. So Kelly raised the most money. So it's a little bit of a pain, but it's just to understand about the z-scores and what they mean. All right. So last one here. Now remember, these little regions right here, we can go to our calculator, but remember this is 34.1, this is 13.6, and this is 2.1, and those basically get repeated over here. And so they say here, the data is normally distributed with a mean of 81 and a standard deviation of 2.5. So this is 81, and I'm going to go up by 2.5 every time I go to a new bar. Identify the regions where only the data for approximately this many kids are located. So it's this many out of 50,000. So I need to know what that is. So 23,750 divided by 50,000. Because they're asking me for a certain percentage, and I need to know that percentage. So 23,750 divided by 50,000. So it's 47.5. It's actually 0.475, but that's 47.5%. All right, so here we go. So look, if you take 34.1 and 13.6, that's 7 there, this is 7, and then that's 4. So look, it's like 47, basically 47.5. So we need to basically select the two things that give me that. So why don't I literally just pick these two? So I could pick region 5 and region 6. So 5 and 6, because that would add up to 47%. You could also do 3 and 4. You could also be weird and do 5 and 3 or whatever, or you could do 4 and 6, all right? But let's just leave it the basics. Let's just do like 5 and 6 or 3 and 4, okay? All right, so that's that. So if you've watched us do all these and these problems right here on these pages, I'll make a third video, and you could do these ahead of time, and then this could be like your little quiz to see if you understand everything for these things right here, okay?